Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for probability. If we have the probability A given that B has occurred is equals to 2 over 5. Second one, we have the probability of B is equals to 1 over 4. And the third one, we have the probabilities of A is equals to 1 over 3. Find A intersect B. Next, probabilities of B given that A has occurred. So kindly focus on the first part where we have probabilities that A given that B has occurred. So here we have the conditional probability. The definition for probabilities for A given that B has occurred is A intersect B over probabilities of B. So kindly substitute the situation. So here we have 2 over 5 equals to probabilities that A intersect B over the probabilities of B, where we have 1 over 4. So rearrange the situation. Probabilities for A intersect B equals to 2 over 5 multiplied with 1 over 4. So probabilities for A intersect B is equals to 2 over 20. If we simplify the situation, and we will have 1 over 10 or 0.1. Next, focus on the question B. So here we have the definition. Probabilities for B given that A has occurred is equals to probability for B intersect A over the probabilities for A. So kindly substitute the situation. Probabilities for A intersect B actually is equals to B intersect A. So here we have 1 over 10 over the probabilities for A is equals to 1 over 3. So the probabilities for B given that A has occurred is equals to 3 over 10 or 0.3. In this video, I'm going to discuss the example for random variable. X has a probability distribution as shown in the table. So here we have the table. Find the value A. So based on the definition, the summation for the probability is equals to 1. So meaning that what we have to do is to add on the probability, kindly refers to the table, and then equate the denominator. So in here we have the denominator 20. So 2 over 20 plus 6 over 20 plus A plus 4 over 20 plus 1 over 20 is equals to 1. So kindly sum up the situation where we have 13 over 20 plus with the A is equals to 1. So A will be equals to 1 minus 13 over 20. So A will be equals to 7 over 20. So kindly substitute the value into the table. So focus on the question B, where we have the probabilities that X is greater equals to 4. So kindly refers to the table where we have the probabilities that X is equals to 4 plus with the probabilities that X is equals to 5. So equate the denominator where we have 4 over 20 plus with 1 over 20. So 5 over 20 will be our answer. Simplify the situation and we will have probabilities that X greater equals to 4 is equals to 1 over 4 or 0.25. Next, focus on the C, where we have the probabilities that X is greater equals to 2 and less than 4. Since this is a discrete random variable, kindly modify the situation where we have probabilities that X is greater equals to 2 and less than equals to 3. So referring to the table, where we have the probabilities that X is equals to 2 plus with the probabilities that X is equals to 3. Kindly equate the denominator, where we have 6 over 20 plus with 7 over 20. So we will have 13 over 20. For the probability, X is greater equals to 2 and less than 4. Next, focus on D, expected value. The formula for the expected value will be summation for X multiplied with the probability. So referring to the table, where we have X multiplied with the probability, and we will have 1 over 10. Then the second one we have 6 over 10, followed by 21 over 20, 4 over 5, 5 over 20. Kindly sum up the situation. So equate the denominator, where we have 2 over 20 plus 12 over 20 plus 21 over 20 plus 16 over 20 plus with the 5 over 20. Sum up the situation where we will have 2 plus with the 12 plus with the 21 plus with 16 plus with the 5 over 20. So the expected value is equals to 14 over 5 or 2.8. I'm going to discuss the example for special probability distribution. The random variable x represents the weight in gram of chocolate chip in packet sold by a supermarket. It is suggested that x can be modeled by a normal distribution with the situation x is normally distributed with mean 100 and the variance 25. So we write the title where we have x is normally distributed with mean 100 and we have 5 square for the variance. A. Find the probabilities that x greater than 108. So step number 1 is to standardize the situation. Probabilities that z is greater than 108 minus 100 over 5. Simplify the situation. Probabilities that z greater than 1.6. So here we have the diagram. Location of z, which is 1.6, then shaded the region. By referring to the table, where we have the probabilities that z greater than 1.6 is 0.0548. For the situation, probabilities that x is greater than 108. B shows that where we have the probabilities that modulus for x minus 100 less than 6.8 is equals to 0.8262. Step number 1 is to define the situation where we have the probabilities that x minus 100 is greater than negative 6.8 and less than 6.8. So simplify the situation. So where we have probabilities that 100 minus 6.8, then we have 6.8 plus with the 100. Next is to standardize the situation where we have probabilities that z is greater than 100 minus 6.8 minus with the mean over with the standard deviation. Less than where we have 100 plus with 6.8 minus 100 over 5. If we simplify the situation, and we will have probabilities that z is greater than negative 1.36 and less than 1.36. Kindly refers to the diagram. Locate the value z, negative 1.36, another one 1.36. Referring to the question, shaded the region. Then we have formula, where we have 1 minus this part. Then we have probabilities that z greater than 1.36 for the part A. Same goes to part B. So what we can do is to multiply with the 2. By referring to the table, and we have 1 minus 2, the probabilities that z greater than 1.36 is 0.0869. Simplify the situation, and we have probabilities that x minus 100 less than 6.8 is equals to 0.8262. And we already shown the situation. I'm going to discuss the example for numerical method. Use the trapezoidal rule with 6 ordinate. So in here, 6 ordinate means that n is equals to 5, subinterval or the strip. To evaluate, correct to 3 decimal places the definite integral where we have the situation, integrate for the function 1 over 1 plus x squared with respect to x for the limit 0 until 1. Step number 2 is to find the h, where we have 1 minus 0 from the limit over the 5. So h will be equals to 0.2. Kindly construct the table. So here we have x naught is equals to 0, followed by x1 where we have 0.2. x2 we have 0.4. x3 we have 0.6. x4 we have 0.8. And finally x5 we have 1. So here we have 6 ordinate and 5 subinterval or strip. Here we have the function 1 over 1 plus x squared. Kindly substitute the value of x into the function y. And we will have y naught is equals to 1. Next, we have y1 is equals to 0.961538. Next, y2, y3, y4, and we have the final value, y5, 0.5. Kindly sum up the situation. Here we have 1.5 and so kindly substitute the situation into the formula. So here we have the formula for the trapezoidal rule. H, where we have 0.2 over 2, multiply with 1.5 plus with 2 multiply with 3.168657. Determine the value, and we have 0.783731. Round up the situation to 3 decimal places, and we have 0. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.